one of the most important things that you need to do on the DITI is to define what you're plugging into the input. And what we mean by that is that when you get a pad, let's say it's an on head, tell the DITI what you're plugging in. So I happen to know that this is plugged into 2A. And you may notice that the DITI has an automatic function. As I jump from pad to pad, it will automatically take you to that pad. And that's a great thing to use once you are using the kit edit. But when you first get started, you need to go into a manual setting so that it doesn't accidentally jump as you're changing gain settings and the like. So in order to change this setting, I am going to jump by using the up arrow to 2A, because 2A is what I plugged this instrument in. So when I go to the right, the word pad type comes in. And what is a pad type? A pad type is simply the name of the pad that you are plugging in. And it could be an on head. It could be an in head. It can be some FSR controller, an E-hat controller. It could be a drum tech pad. It could be a Yamaha pad, a Roland pad, on, and the list will just keep on growing and growing. What you do is just simply find the name of the exact name that you're plugged into the DITI, or get something that's close. So I'm going to put an on head in right now because that's what I have plugged in. See the asterisk on the right? That means that it needs to be entered. So now the drum, theoretically, is ready to play. Once you set your pad type by putting in the name, hitting enter so the asterisk goes away, the general parameters to the right of the pad type have all been pre-done for you. What does that mean? A pad type is a collection of all the settings that are required to make it work properly. And by putting in the word on head, it defined what the input type is. What's an input type? An input type is the actual kind of trigger that we are working on. On the head itself, on 2A, we're acting it as a trigger because it's the trigger. But because we're dealing with an FSR surface, an FSR needs both the A and the B input to work. So if I switch to 2B, notice it still knows it's an on head because it's the entire input, but it sets the input type to FSR. So you will find that when you're working with the DITI, that there are several key input types. There's the FSR input type that powers the A input. Then there's the trigger, and that means that it's a piezo. In other words, the trigger itself creates the voltage that the DITI has to read. We have a hi-hat controller. That means it's a continuous controller input. We have a controller CC, which also means that it's a different kind of controller input. We have a switch, which is a membrane switch pads like the Roland pads. There's an FSR-T, and that means it's a special use of the FSR where the B input both acts as an FSR power source and a trigger. These are the basic input types. We'll get more into input types later when we start actually digging into each of the trigger pads that we're using. But that's the general explanation. So once we set the FSR type, which you don't really have to set up when you set up your pad type, which is a trigger, the next thing that comes up is exclusive. Exclusive means that if you happen to be using two piezos on one drum, it sometimes becomes a problem because whenever you strike any part on the head, both sensors are screaming at you. And that's really one of the big problems that one has when using piezos. So what the exclusive mode does is that basically only allows the biggest signal to win. so that you only have basically a monophonic sound coming out of the pad. Generally, you keep that at no. You only use that for troublesome pads when you can't get rid of the interaction with all of the other things that we're going to be explaining later on. Now, the next important thing is the gain setting. And the gain setting, again, is normally controlled and set for you when you set up the pad type. But you will notice that there are categories of gain settings. There is a normal gain setting of 1, 2, 3, and 4. 1 is the greatest and 4 is the least. Then we have the next grouping, which is a R, which is a resistor that's put into the line. And we have 1, 2, 3, and 4, and that's particularly necessary when we're using FSRs that needs that resistor in there. And also, you may use it for other kind of triggers. Sometimes by adding a resistor in the line, it helps. It puts more resistance on the line and helps in case you're having too big of an output on the trigger. And then we have a capacitor. That's the C. And we have 1, 2, 3, 4, and that does some other things. It acts as a high-pass filter. The point is that you have to experiment when you're starting to get into the world of playing around with different gain settings. And you may want to play with different gain settings if you feel like you're not getting enough output out of the drum, or the drum is giving you too much output, or you don't like the curve that it's doing. Sometimes changing the gain makes a big difference. But again, if I go on head and I hit enter, it's going to select what it likes best. The next thing is the threshold. The threshold basically is how soft do you want to play before the instrument sees that vibration. And you may discover that if you put it too low, you can get some double hits or cross triggering. I mean, this false triggering, because it's too sensitive and it's too much on a hairy edge. So you have a tremendous variation to go from 200 to 0 or 1. When you're dealing with products of FSR, you can bring that threshold way, way, way down, 0, 1, 2, like that. When you're dealing with trigger inputs like piezo, you have to bring it pretty high up, 20, 30, 40, depends on the trigger. The next we have a mass time. A mass time, basically, when you strike a pad, you can have the DITI shut down for 37. And that means that for a short period of time, I believe that the mass time is roughly in half. So that's like 37, I'll say this. A mass time of 40 is like 20 milliseconds or so. That hides away any other strikes. And that's particularly good if you're using a piezo and you're getting some, and the signal that it produces is very, very noisy, that this will mask out some of those signals until it gets low enough, which is below the threshold. Again, these settings are set for you when you set the pad type. Then we have a curve. One of the coolest things about the DITI is that you can create your own curves, and that we've created curves for every pad type that's in the instrument. And there are many, 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 many curves, as you'll see. And if you don't like the curves that we've created, you even have the ability to create your own curves. And there are I believe, 5 user curves. And the way it works, when you call up a user curve, and let's say I want to edit curve number 1, there are basically 16 different points that you can set the MIDI velocity to for each one of those points. So the way it works is that you call up a MIDI monitor program and you strike the pad, and when you notice that, ooh, it made a jump there, you look at the note, you can actually go to each one of the values and change the MIDI velocity at that point. So you have incredible control. 16 distinct points within the curve that you can modify. It's unprecedented in any MIDI controller. And there's 16 different points. Engineers go from 0 to 15, so those are the 16 points. And then finally in the global screens, we're seeing the minimum and the maximum range. That has to do with the values that are created after you train the instrument. We'll get into that in more detail. And then in the global screen, you can reinitialize the instrument. You can do a data dump. You can data dump all kits or just global settings. You can copy one kit to the other. You can have a MIDI merge in on the back. You can change the scan count. The lower the value, the faster the instrument scans the pad. If you go too low, it misses the high because it may the high point of the rising waveform, because it may take longer to get to the rise time than the scan count is. The faster you make it, the more you risk getting not good dynamics. The higher you make the scan count, the better dynamics you get, but it takes more time for it to happen. 10 is a good number to use as a starting point. The DITI scans really fast. Yeah, I'll leave it at that. The interaction level has to do when you're having, even though the training is automatic. Besides the automatic training results, you can actually go to offending pads and change, make it more sensitive to the interaction by raising the level here. It defaults to 7. And then we have special envelope trainings that we'll get into when we talk about the training. And that is all of the global screens.